ones?
It was a tester. Can't.
I said on, not off.
Oh, those ones.
Yeah.
Ones that you see the
I
board.
made them light up in sequence.
Yeah, that was like pretty cool.
All right. Ready?
Yeah.
I mean, I should reweight a bit. Where goes? I think that's.
They'll struggle in.
Strangling.
All right. Well, good afternoon, ladies and gentlemen. I'd like to present you with Nick Barendt from LeanDog. He is a wayward electrical engineer with expertise in cloud, real-time, and embedded systems development. And he is here to give us a talk on a practical introduction to DevOps with Chef. Take it away, Nick.
Thanks, everyone. Thanks, Dan. So, a little background. I'm a wayward electrical engineer from Case. Currently, I work for LeanDog. I'm the director of labs focused on working with early-stage tech startups. I'm also an adjunct faculty member. Some of you remember me from the C course, which I think will be inflicting again in the spring. I do a lot of embedded Linux systems for data acquisition, real-time controls and such, bootloaders, kernel drivers, things like that, user-space data. I also spend a lot of time in the cloud, a lot of Amazon work, a lot of Python, Django, and similar things. Embedded and cloud don't normally come together. It's kind of an interesting mix. So I don't know if you guys know about LeanDog. There's a few people in the room who know a little bit about us. Our office is a boat. It's a view from downtown. Our neighbor is the World War II submarine. This used to be a restaurant called Hornblowers that we took over a couple years ago. We're just finishing the renovation of the boat right now. Otis and Iggy are our mascots. That's the pictures over here and on the hat. We're an agile software development company, which means we do two primary things. Companies that do software development in-house, who decide they want to move from a waterfallish model to a more agile and lean development methodology, will hire us, and we'll embed coaches at that company for some period of time. Both engineering coaches, people who work with the developers directly doing test-driven development, acceptance test-driven development, continuous integration, continuous delivery, stand-ups, such, and all the way up through iteration management, release planning, story mapping, story cards, all these sorts of agile techniques. So we'll do that at clients. That work is outside of Cleveland, so we have road warriors who do that, travel 50 weeks a year. We do software development for clients as well. So we have developers in our studio on the boat who do web, mobile, some desktop, some embedded work, Python, Ruby, iOS, Android, various .NET flavors, Java, and we're always looking for talent, both co-opt interns and full-time. So pick up a card if you're interested. We also, you may want to check out, we have a page called Dog Treats on our site, which has a lot of material that we've generated that we give away to clients. There's a book on agile development, kind of a one-page summary of the most of the practices. And there's some other useful things in there that people will find. Some other training tool techniques that we use. But today we're going to talk about DevOps. So what is DevOps? Traditionally it's become, particularly in the enterprise world, that the development organization is separate from the production or operations group. So the developers generate source code, literally or figuratively throw it over the wall to the operations team, who puts it in production and then manages the infrastructure, gets the calls at midnight when things go down. And it works to a certain extent, but we'll talk more about what the issues are there. So there's this idea of DevOps being the mix of development and operations, either a DevOps team or individuals who can kind of walk across the development organization and the tools and techniques and development practices into the operations side. And this is prevalent in a lot of small shops. Startups and stuff have to do all of this themselves. So that's kind of where DevOps comes from. It's kind of a portmanteau word. And it comes around in the last couple of years as kind of an outgrowth of the Agile and Lean principles and practices and this idea of we want to minimize the work in process we have that is software that we've developed that isn't in production yet, that we've invested in. It's equivalent of WIP, we talk about WIP in the manufacturing world. We've invested in some sub-assembly, putting some widgets together, a circuit board and an iPhone that we assemble and put on a shelf somewhere. that we've invested capital in but cannot deliver any value to the business until it becomes part of a sellable unit. That's WIP. The software equivalent is software we've written that isn't in production. That isn't, we're neither not delivering value to the business or not getting any validation from the customers that this new thing, this piece of the web or this mobile app or whatever, is of value to them. Which may just be recreational value for games, but maybe more business critical, insurance claim systems or whatever it might be. So you've probably heard of the terms continuous integration. I hope as an undergraduate you've heard it by now. As a technique to improve overall software quality and make releases less of an issue. And then moving from continuous integration to continuous delivery. It's a little beyond the scope of what we can talk about today. But this idea is we want to make releases a non-event. And we use things like test-driven development, behavior-driven development, acceptance test-driven development to improve the quality and reduce the stress around release cycles. Nobody wants to be on a death march. So this idea of DevOps is really more of a holistic view of the software world and the business aspects of it and the infrastructure. That the code and the infrastructure are pretty much inextricably linked in most organizations. So let's accept that and create our teams and our thinking and our tool sets around that. So specifically today we're going to talk about configuration management and a little bit about deployment automation. So there's a sample application we'll be running through that's running on Ubuntu 12.04, the long-term support version. A little Apache, a little Python Django, a little Postgres for persistence. So we'll kind of just walk through the stack real quick, make sure everyone's familiar with it. So we have Apache 2. There's lots of other ways you could deploy this, Nginx, gUnicorn, whatever you want, but this is a pretty common deployment configuration. Apache 2 serving static content, using mod.wsg to run our Python code under Django. We'll be using Postgres for our persistent store. So static content, aka files. HTML, CSS, JavaScript, images, whatever other static things that we're serving up that are effectively dist files that are not compiled or interpreted. And then mod.wsg. So WSG is a web server gateway interface. It's CGI, fast CGI, WSG, kind of all these TLAs. Specifically designed for Python, and there's lots of different layers that will ride on top of WSG. If you write your application that's WSG compliant, lots of frameworks that do this for you. You can plug into Apache with mod.wsg or gUnicorn or a bunch of other things. Web enable your code and get somebody else serving you on port 80. So mod.wsg is an Apache plugin, executes our Python code. Python's dynamic language, so of course there's compilations and VMs involved and such. Postgres is one of the relational database management systems that's Django's ORM supports. Obviously you can use MySQL, SQLite, or Oracle, anything you want like that. So how do we deploy now? So let's talk about how we do it the hard way first. And when I said the hard way, this is the way the developer typically does it the first time, as you're learning how to bash Postgres into the configuration you want and make Apache, figure out where the magic needs to be in the config files to serve your app up. So we're going to start with a bare bones system. So some videos, hopefully they're partially readable. We'll see those in the back. So we're starting with a generic Ubuntu system, installing a bunch of packages, distro level packages on Ubuntu with apt-get. And this is running faster than real time. It's painful enough to watch at 5x speed. So here we're going down, talking to this one's running local on my VMware Fusion instance on my laptop. Now we're installing mod.wsg, getting the libapache. Oh, I didn't remember the name. Tab complete. There it is. And we can actually get the full path. And install that and all its dependencies, and we have to have an editor, so we'll use Vim. Oh, now we have to get Postgres. Need a database. Okay. So we're done. So now we at least have the packages installed. And this is, again, all manual. So we're going to use virtual environments. So in the Python world, we have, ages ago in the Windows world, we had DLL hell. You'd have your application, it would require DLLs. Different application machine would require different versions of the DLL and would break with other versions that we're running. So virtual environment in the Python world is a way to isolate third-party library dependencies. It's equivalent to Ruby's RVM if you're familiar with that. Basically, it gives you your own copy of the Python interpreter, whatever version you want, 2.6, 2.7, 3, whatever, plus whatever third-party libraries you need to run your application. pip is the Python package management interface. We used to use easy install. Pip has taken over. Pip will allow you to install a Python package, either pure Python or one that requires some native compilation to the binary level, as you're hooking into an image processing library or something else that is C-based and you're putting a Python wrapper around it. And then also, at the higher level now, we want to work with a manifest of all the packages we need and versions of those packages we need, because we need to make this thing repeatable. We want to lock down the versions that we know our application works with and deploy with those. We can upgrade them later in a test environment if we want some new feature, but when we're debugging things, we want to minimize the number of variables. So pip allows you to specify a requirement. It's by convention called requirements.text. It doesn't really matter what you call it. But it basically looks something like this for our simple application. It's the name of the library, and you can specify a version with an equals equals. There's other versions of this you can use greater than or equal to some package version to verify you have at least some level of support within that library. So Django, the web framework, and then CyclePG2 is a Postgres client adapter for Python. So we'll create the virtual environment. So that created the virtual environment, which is basically when we activate the virtual environment, it's doing some fancy footwork with the environments and environment variables and paths. So now we're pip installing the requirements file, so it's going to grab all those libraries that we want, whatever version we specify, by going out to the Python package index. That's actually compiling code there, GCC, as a side effect of downloading those pieces. And it's grabbing all their dependencies as well. Some of the other libraries require other dependencies that we captured. Now we're going to configure Postgres. This gets more fun. So we have the default version of Postgres installed, but by default on most systems, Ubuntu and most others, Postgres is pretty locked down initially, which is the same default. But we need to modify it so it's actually listening on a TCP port. By default, it'll listen on a Unix domain socket, which is fine for a local application, but as soon as you have a database that needs to be connected from multiple web instances, that's an issue. We want to create, we have to modify the authentication parameters that are used. We have to create a user, we're calling it roster, it's the name of our application, and we have to create a database within the database cluster called roster. So this, unfortunately, requires becoming root, hand editing some files will enable TCP. We're going to go modify the TGHPA file, which is the authentication list. We're going to create the user. It's all pretty painful stuff to do. Now we're going to create the database that's owned by that user that we just created. Now we're going to test it, make sure we can connect. Ah, shoot, can't connect. What happened? Become the Postgres user. Oh, let's restart Postgres. That always helps. When in doubt, restart the daemon. What did we do wrong? Well, let's become the Postgres user. Thinking still. We'll become the Postgres user on the system, which also, because of the default parameters, make you a super user in the database. And we'll just bash the password to reset it on that user account. Hooray, we're in. Okay. So that got us to a point where we could actually run some code on the system. Now we actually need to get some source code over there. So we're going to use Git. If you don't know Git, you better learn it. Or Mercurial, one of the two. Pick your poison. So that pulled the code over. We can actually run now, and I'll delay it. I'll say a little bit later what it's doing. But that wasn't very pretty, and it wasn't easily repeatable. There's a lot of hand editing of files and manually installing packages. We'll come back to that. So what does this app actually do? It's a little class roster thing. Departments, classes, students, instructors, just a really stupid CRUD app. This is the only view I wrote. Everything else that we're just looking at is the default Django admin views, introspecting the model objects, and enrolling people in classes. So back to the story. So the configuration. What we're looking for in here is repeatable process that works on a minimal system. So we can always take a system from a baseline and get it into the state we need it in. So a tip for anybody who's doing this, and most people are, right? You're running your own web apps, your own web servers, and you just keep bashing it until it works. Virtual machines are really handy for the development and testing of these pieces. Whether you're running VirtualBox or VMware or whatever, it'd be very, very valuable to allow you to snapshot the state of the system, like after a vanilla install of Ubuntu or whatever you're using. Snapshot it at the disk level and the OS and RAM level. Your VM supports that. Test your configuration, then roll back to the snapshot after you make your fixes and changes. It allows you to change and test the code very easily. So, for instance, this is a partial snapshot of my version tree of the VM itself when I was developing this talk. There's actually, I think, about 30 snapshots. It's very free. So we had a pretty painful process there. How do we improve this? So the minimal level will be, well, let's take a few notes. So we need Apache 2 and Python 2.7.3 and Git and Vim, and then there's a bunch of Postgres manual operations we're doing. That's something. At least now I have a document I can share with the developer next to me or put into the source control system. But we can do a little bit better than that pretty easily with some scripts. So you can create a script. I tend to call them things like prepare Ubuntu. It's a bash script, and it just apt-gets the packages I know that I need to take a vanilla system to the state I need it in terms of the distro level packages. Now, this isn't quite true for this application because I've been running it on the Ubuntu desktop version, which comes with Build Essential by default, GCC and Make and all those things. So if you went to run this on Ubuntu server, it would probably crash horribly and you have to manually install a few more packages. But again, it's a start. You can automate the creation of the virtual environment, blow away the existing virtual environment that's in place, create the virtual environment, invoke pip within the virtual environment path, install the requirements. I guess it's pretty far. But how about all those config files we had to edit? Yeah. We could do some horrible shell script stuff to modify those config files. I mean, you can do this with sat and awk, and God love you, but it's not really a good way to live. So let's talk about Chef. But let's wait just a little bit longer. What do we really want in the system to help us automate configuration of a computer? So I would like configuration to be source. I don't want to be mucking around with registry files and things like that, or registry databases. Be optional, or ideal if it was source code itself, because then I can stick it in the version control system, I can edit it with anything. I can diff, I can look at the changes in the configuration, very powerful. And then the next level is I actually want to tie my code, my production code, to my infrastructure configuration source, such that when I do a release, they are tied together. And I can be working on development versions of both of those asynchronously from what's in production and merge those pieces in the branches when necessary. I would also ideally like it to be a declarative environment, not an imperative one. So I declare the state that I want some resource to be in, and let somebody else take care of the dirty work of how it gets into that state. So here we have a DSL. This is a little chunk of Chef code. That's a domain-specific language for configuration. And in this case, I'm specifying that there should be a database user, that's the type of resource, whose name is roster. And then there's a little bit of semantic sugar on the DSL. It's a Ruby block, basically. And I want the password for that user to be Spartans, and I want it to have access to a database called roster within the database system. So this leads us into Chef. So Chef is developed by Opsco. They're a private company. It's open source. It's been around for about 3 years. It's under an Apache open source license. And it's basically a Ruby DSL for managing configurations and recipes and cookbooks. They kind of carry the chef analogy kind of far, a little too far for my life. It's a little too cute. Now, there are other systems like this you should be aware of. There's Puppet, CF Engine, Salt, other systems like this. And there's kind of a Puppet versus Chef is sort of a VI versus Emacs or static languages versus dynamic languages argument. It's really, you have better things to do with your time than argue about these things. Pick one. So this is kind of the Chef architecture in the broad scheme. There's Chef server, there's a Chef client, and then there's Knife. Again, cute analogy. But it's actually a little bit more than this. So the way Chef Server works is there's actually CouchDB running in there, there's Solr, there's RabbitMQ, and then a whole bunch of other stuff. And you're like, but I just want to run a few machines. Well, the reality is you can use opscode's Chef Server. They'll give you Chef Server source, or you can just host it at their site and run it. But if you really just want to start simple, then I suggest Chef Solo, which is what we'll focus on right now. So Chef Solo is essentially the Chef client, but it works without talking to a Chef server on the network. It runs just using local resources. It's much simpler as a starting point to start learning how to use Chef effectively, and it's pretty quick to use to debug your recipes as you're developing them. And the recipes are inherently the same recipes as you would use with Chef Server, so you can use this to develop them or start with Chef Solo and eventually migrate to Chef Server and kind of the full-blown system if you want to. So some important concepts here in Chef. So we have nodes. We talk about as servers, computers, machines. We have resources, which are abstractions of the thing you're configuring. A resource is a pretty generic concept, as you'll see. We have recipes, which are collections of resource descriptions, that is the resource and the state I want it to be in. Then we have cookbooks, which are collections of recipes and some attributes that go with those recipes. We'll talk a bit more what that means. So nodes, Chef is pretty platform, supports several platforms. It's primarily Unix oriented, so pretty much any Linux flavor you're going to use, we support it. OS X is pretty well supported. There is some Windows support. I haven't used it. I've heard it's improved, but I don't have any hands-on experience with it, so I can't really comment on it. So you can think about a node. It's a computer. Resources are a little more abstract. So in the simplest case, we have a file resource. So these are some examples of the built-in resource types that Chef understands. So files, that's a file you want put somewhere on the computer. Easy enough to think about. A template is a file that you want interpolations to be done or string replacement of the template before it sticks the file somewhere on disk. So templates are often used for configuration files, like the Postgres configuration files or the Apache configuration files, where you have a template and certain substrings within it need to be replaced based upon the deployment that you're doing. Execute is kind of the system call. It's the back door. You can put any command line operation you want in there. Call scripts, talk to standard command line utilities, whatever you want. You can specify cron tasks, links being hard or symlinks within the file system. Create directories and set permissions on any of these things as well. Create users and groups at the operating system level, and do checkouts from Git or Subversion or several other source control systems. So talk about recipes. So this is a recipe. That includes a couple resources. So the first resource type we're seeing is package. So package in Chef world is a distribution package. On Ubuntu or Debian, you'd be using apt, aptitude, apt-get, whatever, to install that package. On Red Hat, Fedora stuff, you'd be using yum. And this is an abstraction of what a package is and how it should be installed. So the package we're requesting is libpqdev. This is the Postgres client library, the development version, which includes the header files because we want to compile some code against it. So we're saying, when this recipe executes, I want this package to be installed. How it actually gets installed is a lower level issue within Chef. There are providers that handle this stuff. Device drivers, if you will, that are specialized for Red Hat or Fedora or whatever. But at the Chef level here, I'm going to say package libpqdev, and that package will be installed for me. So the next package we want to, or resource we want to talk about is a virtual environment. So we'll look at some of the cookbooks in a minute, but there's a pretty complete Python cookbook available from opscode in the GitHub repository. And virtual environment is one of the resource types it supports. So here I'm creating a virtual environment. This stuff here, this is a Ruby hash dictionary. And the thing that goes here is the path where we want the virtual environment to be created within the file system. I want the interpreter to be Python 2.7, and the action on it is create. There's some other create is the only obvious one here. There's delete and a few other actions that may make sense if you want to remove this in a future release. So let's talk about a little bit about what's here. You'll see node. Node is a variable that, again, we're talking about nodes in the chef space, are representations of the computer or the server. So node is a data structure that contains information about the current machine that we're running on, that is created and populated before our recipes execute. So in this case, this is effectively a shortcut for colon roster is equivalent to colon roster colon. So we're looking into a dictionary key here and grabbing another key out called virtual environment directory, where we want this created. So this is a configuration parameter we passed in that allows us to move the virtual environment around just by modifying one code place. It's a dry kind of thing, don't repeat yourself, why it's done that way. Here we have some Ruby variables and some Ruby code. And again, Chef uses Ruby, but you don't need a lot of Ruby experience to use it. In fact, there's some great tutorials on just enough Ruby for Chef. Here we're basically synthesizing a string, a path name, based on the virtual environment, and we want to run pip within that virtual environment, which is in the bin directory, subdirectory of the virtual environment. And this is just a file join thing. Requirements.txt is synthesizing the path to the requirements.txt file in our source code repository. And then we're going to invoke the execute resource, which again just allows you to run command line stuff. We're going to invoke the command. This is string interpolation, basically. Take pip command and shove it into the string here. Install, and then install the path to the requirements file. Recipes are executed from top to bottom. This is important because you need to be able to, when you're down here, rely on other resources being constructed in many cases before you get your code executes. So cookbooks are collections of attributes, templates, and recipes. So this is the Postgres cookbook. So there's a couple directories, attributes, which typically only contains a default .rb. .rb is a Ruby extension. A default file that specifies some default attributes for recipes around Postgres. There's some metadata and some licensing stuff, and typically a markdown README file. And then a collection of recipes. So you'll see there's a client recipe, which is to install the client Postgres packages so you can connect to a Postgres server. There's the server recipe, which installs the server and pieces of this around the server. And then you can see there's two specialized versions to install it on Debian or Red Hat that you don't actually invoke. You just specify the server recipe itself, and the right sub-recipe is invoked for you. And then templates I mentioned, these are Erebus template files. So again, we had to go in and manually modify that HBA file, PGHBA, to change the login supported features on local and TCP. There's a text file there, a template file that gets string interpolated at runtime. So there's tons of cookbooks out there. I think there's 140 of them or something in the ops code repo for OpenSSH and Perl and Nginx, and there actually is one for Django, but we're going to do this all manually just so you see how it works. So there's lots of support out there. Odds are that unless you're doing something very esoteric, there's something to start from. I mean, they even have Erlang and RabbitMQ and some more niche things. So there's this important idea of convergence within Chef. So Chef attempts to make the machine's configuration match the desired configuration that you specify in your recipes, resource by resource by resource. Sometimes things will fail, right? You go to download some third-party packages from the Ubuntu servers or something, and they're down, or there's some temporary network outage. The important piece here is if you run Chef again, and that error condition doesn't exist, it will plow forward from wherever it left off, manipulating the system state to where it needs to be. So it converges over time to the desired state. Resources in general, the resources in the Chef world are generally idempotent. So when you say there should be a database user named roster whose password is Spartans, if that user exists in the database already, it won't create a new user. It will modify the password if it isn't already Spartans. If it doesn't exist, it will create it. So you can invoke the recipe as many times as you want, without creating bad side effects. Now, there are some resources like execute we saw was a system call. It's executing whatever command line path you want to give it. There's no way for Chef to make that identity. You can, however, you can create side effects of your execution, touching a file into existence or any of the standard kind of Unix tricks to show that this thing has already been done. Don't run it again. But in general, most of the resources that are built in or provided in the libraries are identical. So it's meant to be robust, and this idea of try again. And in fact, if you run Chef's server, the way the normal configuration works is the clients talk back to the server on a regular basis, typically every half an hour, and will get their new configuration every half hour and be continually converging the machine into the new state. So if you're not changing the state on the server for the machine we're talking about, fine, it's where you left it. If it failed, it'll try again to get it into that state. And if you change the configuration of the machine on the server, all of the clients connecting to it that are meant to be in that state will eventually manipulate themselves into the new desired state. So it's a sort of this idea of continual convergence to wherever you want the machine to be in sort of some weird state space. So how does this actually work? Well, so what happens is, I mentioned that node attribute, or the node hash that we're looking at. So at runtime, the defaults that we saw in the attributes directory, the cookbooks and such, are merged with the node attributes. There's a Ruby package that Chef uses called OHAI, that does a lot of machine introspection and populates that node hash with all sorts of information. What distro it's running on, how many cores it has. So, you know, reaching down into the proc directory on Unix, cat proc, CPU info, and things like that. What's your MAC address? You have multiple MAC addresses, they're all there. What are the IP addresses associated with all those?